to my video. My name is Arshal and this is operating system lab experiment number 7, contiguous memory allocation. So in this experiment we will see what is contiguous memory allocation and see the techniques that are used for the worst, best and first fit in this experiment. So let's begin the video. So in contiguous memory allocation, one of the simplest method for the memory allocation is to divide memory into several fixed partitions. So means if there is a memory that is divided simple into several fixed partitions, so that is known as the memory dividation, and each of the memory can have each of the process, and in the multiple partitions there are many processes that can be active. So when one process is terminated, then the other process comes, and after that the process goes on. So in that the memory is swapped so that the load can be minimized, and see the sufficient size of the memory. For that we use the strategy such as the best fit. So that the best fit is used to this is the best fit. So this is the initial memory. So this initial memory, this is having 1 2 3 4 5 6 and 7. So there are 7 partitions there, and in that 1 and 2 processes are there, and this is the third. So in the best fit, it what will do. So let's see. So first we will see what is the algorithm. So the memory started, get the number of memory partition for their size. So the second step is we will get the memory partition, and for the third, get the number of process and values of block size for each process. For that we will get this type of block, and then each type of process will be there in the block. For the first, that is the first fit. So this is the first fit. So here it will see that the algorithm searches the entire memory. Means it will search the entire memory from this, and then the entire memory until the whole which is big enough encounter. Means which is big enough. For example, as we see, this is the block, and at the last there is a big hole. For that it will go there, and it will allocate for that. So this is known as the first fit. For the second, the best fit, it will go and search the smallest hole, and it will allocate. So here in the best fit, it will see the smallest hole. If there it is the smallest hole, so there it will go and fix there. Next, it what will do for the worst fit, it will see all of this, and when there is enough space, means that process, means this is having 10 kb, and for the first fit, here is suppose 100 kb. So 100 kb it will go first fit, and then it will be allocated, and the enough will be remaining. Sorry, if there is a if there is a process of 15, and the this block is having 20, so there it will go, and it will allocate for the 15, and the 5 it will be maximized. Means it will occupy. And next, for the best fit, it will go and see the next one, and it will see the greater than that process. Means it was 20, if there is 40, then it will go and allocate. And for the p3, if there is 100, it will go for the worst, and then it will occupy 15, and then the remaining part will be available. So that is known as for the first, best and worst part. So this is known as the analyzation. So let's see what it will do. So the best fit, it will go, and it will give input such as the block size, how many block size containing, how many block numbers are there, and process size. So there it will go, and this will allocate the process size and block size, and then it will show the actual big hole, and then it will go, means smaller than big hole, and then it will allocate the process. For the first bit, it will see the topmost memory, it will search that, and it will be enough for that, and then the biggest of the whole, then it will allocate, and if it is not there, it will go to the next, and it will check. So this is known as the first fit. And for the worst fit, it will see the largest hole, and if there is a place, then it will occupy, and then the remaining space that is accommodated in that. So we will see the program for the best fit. So this is the best fit program. So let's see. So the first, it will ask the number of blocks, how many blocks we have to enter, number of processes, how many processes are there, and it will ask the size of each blocks. So this will ask the size of each blocks. Then this for loop will take the blocks. This will ask next size of processes. Then it will uh, this will enter the processes in that. So next it will go, and it will see in the memory if there is available. If it is available, then it will go, and it will occupy the high, means if there is a memory of 9999 99999, so like that, if there is memory, so it will check till the fullest memory, and it will see the smallest one. If it is smallest, means the largest one, it will minus from that. So if that is smallest, then it will go, and it will occupy the fragment, and then it will go to the memory, and it will occupy, so that it will go, and this will print the fragment that is it is lowest, and then this will print the best fit. So let's check the output for the program. So here, if we see, if I enter the number of blocks, that is 5, and the processes are 4. So let's go. If I type 10, 5, 3, 7, 4, and the number of processes, there will be 5, 4, 7. So this it will go to the each process, and it will show the process size, block number, and block size of fragment. So if it is having, then it will go, and it will allocate. So for the first fit, we will go and check the first fit program. So for the first fit, it will allocate the flag, means it will allocate, and see the block that is larger than, means less than the larger role. It will ask the number of blocks. It will ask the number of each blocks, means size. Then it will enter this. It will ask the enter the number of process, and it will ask this, the number of process. So the processes are entered now. Next, it will go to the for loop, and it will allocate if the for loop is there, then it will go inside, and it will print that the flag of j is equal to 0, and then this is the block size, and it will check it is greater than is equal to p size, then it will allocate the memory, and then it will be blocked. So this it will go and check whether it is available. If it is there, then it will allocate the memory inside that. So this will print the allocation. So we will see the program output. So if I entered here number of blocks 5, for the each blocks, if I enter 4, 6, 9, 1, and 8. Number of processes, if I entered here 3, 10, 7, 4. So if I check here, it is showing the block numbers are 5, block sizes are there. If this block is available, then it will allocate this. If it is having the enough space, then it will not allocate this, and the process size it will show. So like that, it will allocate for the first size, first fit. So next we will see worst fit. So here it will ask the same as previous, that enter the number of blocks, enter the number of files. So it will enter the block number, it will ask the number of files. So here it will go, and in the memory it will check if it is a larger hole, it will go inside the temp. It will minus from that if it is equal, it is not is equal to 1. If it is not is equal to 1, then it will go inside the loop, and then the temp is greater than is equal to 0. If it is there, then the topmost element, it will go, and then it will be allocated at the top. Means from the first it will search, and then it will go to the largest hole, and it will allocate so remaining memory that it is there, so that it will be remaining, and it will show the worst fit. So this will print the worst fit. So this is the output: 5 into the 4, 8, 10, 3, 4, 5, 9, 6, 7, 1. So this it will show the file numbers at their file size, block number, block size, and fragment. So like this it will show, and it will print the number of block size and fragment. So it will show in the memory, and it will occupy the largest hole, and then it will print the output. So like that it will allocate, not allocate, and then it will print the best, worst, and first fit. So this was experiment number 7, contiguous memory allocation of operating system. Like, thanks for watching my video.